Hello, this is Mr. Wyrick again, and I'm here to talk to you about Lesson 2.5, the fifth lesson from Chapter 2. This will get us up to the midpoint of our chapter, and we have a midpoint test that we are going to take, so we'll do a little bit of review. From this point, we might take an extra day to do some of the work from this lesson, and we will move forward from there. So, Lesson 2.5 is using the stuff that has come before, and we're going to talk about postulates and paragraph proofs. We're finally getting into proving if something is correct or not with multiple steps. So all the stuff that we've been doing over the last few days, where we've been determining if things are true or not, and we've been talking about different kinds of reasoning, we're now going to use that combined, kind of moving forward. The first thing is the postulates or the axioms. If you have a postulate, there's no need to prove it true. It is already true. It's always a true statement, and we don't have to work for anything there. These are going to be our building blocks. These are going to be the things that we use to move forward and say, if this is true, we're going to form like if-then statements. If this one is true, and we know it is, it will prove this other thing. And if this one is true, it'll prove this other thing. And we can use the combination of those to prove something else. So we're moving forward with that. You can analyze statements, which is what a lot of this exercise is going to be, is analyzing statements with the postulates or axioms. I've written one down here. It's 2.2. Make sure you copy down this one. As far as your notes go, you might want to make a little cheat sheet on a card or something like that. We may even try to get a foldable done for this one when you come to class. If we have three non-collinear points, 3 points that don't fall on the same line, they will define a plane. There's always one plane that goes through any 3 points. That's the bare minimum of what it takes. Now we can have millions of points on a plane, and if you're looking at a plane, you can name a whole bunch of points. But it takes at least 3 of them named to make a plane. So knowing that, then we can move forward and say, okay, if they give us A, B, and C, and here's A, here's B, and here's C, and not all 3 of them are on the same line, because that's what non-collinear means, then that will always define a plane. If they just give me A, B, C, and they say that there are 3 points, but they don't necessarily say that they are non-collinear, and there's no illustration to prove that they are non-collinear, I would say that sometimes that statement would be true. There's always the chance that they are all on the same line. That would make it not true anymore. And then never true would be if we have one single line and we have points A, B, and C on that line, one of these points needs to be removed from that line and placed somewhere else in order to define a plane, to say that this is definitely a plane. So then that statement, if we have points A, B, and C, and they form a plane, that would never be true. If we have just points A, B, and C, there's no picture, there's no saying for sure that they are non-collinear. That's sometimes true. And then the 3, and it shows that they are separate, that's always going to be true. So that's what we're doing moving forward here. We are analyzing statements like this here and determining if they are true or not. Now, when we get into proof, what we're talking about there is a process by which we take these postulates and we prove something else. Okay? So this would be a very, very basic one. We can say, okay, this happens. As we move forward in geometry, we'll end up with ones that are multiple steps. If you ask your parents about geometry, this will be the one thing more than likely that they remember more than anything else about shapes and anything. We did those proofs. Boy, I tell you, we did proofs and proofs and proofs. Okay? A theorem is a result of applying postulates over and over again and finding a result. So once we have a theorem, we can then move forward. These would be like our second step. So we got our building blocks, we got our second step to move forward. Okay? We're going to use these things to form a deductive argument, like it's saying in the front of this chapter, and then we're going to do a paragraph proof or informal proof. That's what we're going to be addressing with this lesson first. Okay? You'll just be saying, because of this postulate, this has to be true. Because of this postulate, this has to be true. So we can use that information to move forward and say that this is going to happen. Okay? It's going to be a little bit of a messy process at first. One of the things you definitely need to do, again, for sure get this down, make sure you have that table from the very first page of the chapter in your notes, and your notes open so that you don't have to flip your book back and forth. You can say, okay, postulate this, so that you don't have to write down this every single time. 3 non-collinear points always define a plane. You can just say postulate 2.2. That'll save you a little bit of time, save you a little bit of space moving forward. Be sure if you have any questions on this, you're raising your hand during class, you're asking before we start in on the grading, and we'll see you back next time. I'll probably post some stuff as a review. I'll post another video kind of going over some of the stuff from the review.